Hello everyone, welcome to this video. In the last video we saw what do you mean by level curves. So suppose you have a mountain of this kind, then the level curves would be the curves having the same distance from that of ground. At every point of this level curve, say your function, you have the scalar point function as phi of xyz, that is equal to some constant c. In that case, this function on a particular level curve will have the same distance at every point for this particular curve. Now, talking about the gradient. If I talk about gradient, now basically what I am saying, suppose there is a person who is standing at the bottom of this mountain peak and he is intended to reach here. So what he can do, he have to take that person is expected that person require the path where they feel the time to be minimum. That means that person is looking for that particular path for which it would take the minimum amount of time to reach from here to here. So what could be that path? That path is the perpendicular in this direction. So suppose for different level curves, these are different level curves, what this person will do, this person will start from ground, go in the perpendicular direction, reach at this level curve, go in the perpendicular direction to this level curve, reach here, go to the perpendicular direction, reach here, perpendicular direction, reach here, and finally he will reach to the top, right, in the minimum amount of time, and he would say, yes, I am happy, right? So basically what he did, he took the path which is perpendicular to this level curve, because otherwise if he would have taken the path here to be the tangential path instead of this normal path, he would be traveling round and round the mountain, but being at the same height, right? So this won't work for him otherwise he will go like this. So that would be the maximum time according to this. So in order to reach the mountain fast enough, so he would have to take this perpendicular path. So let me define this situation mathematically. So how it is related to gradient, so this will be clear to you in a moment. So for that we have some notations. So let me define the notations first. Suppose we have some point P of x, y, z. This is any point in the given region, any point on the level surface. So let me define the level surface by saying phi of x, y, z is equal to c. So this is our level surface, and corresponding to this point P, I have another point Q of x plus del x, y plus del y, z plus del z. This be some other neighboring point of P. So that means we have some displacement in the point x, some displacement in the point y, and some small displacement in the point z. Then if I write by r vector, this represents the position vector for point P, and r plus del r vector, this represents the position vector for point Q. And if I define this r vector to be xi cap plus yj cap plus zk cap, so that means the point at which this P is present is at x, y and z in the 3D plane. So therefore in that case, what would be my r plus del r vector? That would be equal to, we have displacement in x as x plus del x I cap plus y plus del y j cap plus z plus del z k cap, right? So this is the vector that you will obtain for the vector q, right? So suppose this is our level curve. On this curve we have this point P, this point as the point Q, right? And this is some point origin. So its position vector would be represented by R. Its position vector here, suppose this is the point Q, is represented by R plus del R, right? So what would be this vector? P Q, right? So let me calculate the position, vector representing the vector PQ. So it would be the position vector of Q minus the position vector for vector P. So it would be equal to vector R plus del R minus vector R. So this would be equal to delta R. And what would be delta R? It would be delta x I cap plus delta y j cap plus delta z k cap. So this would be a vector P. Now if you see this curve, this is some curvy curve, right? And now if you see, if you move or shift this particular point in the direction of P, so this chord would obviously tend towards the tangent at the point P, right? So this will act as a tangent to this point P. So we say that as the point Q is tending towards the point P, the line PQ tends toward the tangent to P at the given point. So that means whenever Q is tending to P, we are taking this limit. This, what is this? This is delta R. So we are taking this delta R going to 0, right? So we can say whenever your delta R goes to 0, this quantity will become dr. And what is this? This is going to be equal to limit delta x going to 0 of delta x I cap plus limit delta y going to 0 delta y j cap plus limit delta z going to 0 delta z k cap. So basically your vector dr, this becomes equal to dx I cap plus dy j cap plus dz k cap. So this is what you obtained for the vector dr. Now you have the the vector representing dr. Now this vector lie on tangent plane to the surface at P. So therefore we can calculate the gradient of phi dot with the vector dr. Let's see what this come out. So we will relate finally the quantity gradient phi with that of this position vector, which the vector which lie on the tangent plane to the surface at P. So let's see what this dot product represents here. So for del phi we know this definition. This is del phi by del x I cap plus del phi by del y j cap plus del phi by del z k cap. So this represents your gradient of phi dot product with dr. And what is dr? dx I cap plus dy j cap plus dz k cap. And now you know how can you perform this dot product. So you multiply the component of I with the component of I here. So this becomes del phi by del x into dx plus this component becomes equal to del phi. You multiply this quantity with that of this quantity, the component of j. So you have del phi by del y into dy, and then similarly for the third case you multiply these two. So you have del phi by del z into dz. So this is the quantity, and here if you see what is this, this is the complete derivative for the function phi, because using the chain rule, if phi is some function of x, y and z, so that means if you wanted to calculate d phi, so firstly you will calculate its derivative with respect to x and then the derivative of x, right? And then it would be the derivative partially with respect to y and then the complete derivative of y and then the partial derivative of phi with respect to z and dz. So this is how you define the things. So this becomes equal to d phi. And what was your surface phi? If you remember, the surface phi of xyz is equal to c was the level surface. So that means on whenever you are moving on this particular surface, there would be no change in this position c. So whenever you take its derivative, it would be going to, because this is some constant quantity, this will be going to 0 always. So therefore what we got the gradient of phi dot with dr vector, this is equal to 0. Now this is equal to 0, that means the given two vectors, because this vector is also not 0, this vector is also not 0, therefore they have to be perpendicular to each other. So we can say the vector del of phi, that means the gradient of function phi, this is perpendicular to the vector dr. And what was our vector dr? Vector dr, this vector lies on the tangent plane to the surface at P. So we have fixed some point P, and this vector lie on the tangent plane to the surface. Therefore we say because these two are perpendicular to each other, therefore we conclude that this gradient of phi, this is a vector normal to the surface phi of xyz is equal to c, where c is constant. And this is what I have showed you in the figure. So this is a vector which is normal to the surface. What surface? The level curve, right? So if we go back and look at our diagram once more of this particular mountain, so for this particular level curve which represents phi of xyz is equal to c, I'm saying our gradient vector will tell me the direction which is perpendicular to this level curve. So that would be maximum. So basically the gradient that gives me the maximum rate of change of some function phi, right? So if some person know mathematics and they model the mountain as some scalar point function, and then they calculate what is the level curve. So if that person calculate the gradient of the function phi, so in that case they exactly know in what direction they have to move by knowing this del phi, and that is it that they require. I hope you understood this concept. Well, that is it for this video. Thank you for watching.